The quarrelsome integrals. For this problem, uh, we first need to recognize that if this is y, this will be y inverse. Yeah, if you want to take it, let's suppose y equals to uh, 22th root of 1 minus x to the power 2020, and then we get it to be y to the power 2020 equals to 1 minus x to the power 2022 is equals to 1 minus x to the power 2020, and x to the power 2020 equals to 1 minus y to the power 2022. So this is x equals to 2020 in the order of a root, and then 1 minus y to the power 2022. So you see y inverse is just 2020 order root of 1 minus x to the power 2022, which is exactly this thing over here. Yeah, so now we are sure that the second one is the inverse of the first one. Now we will just we will need to know a property of inverse integrals, which is like this. If we have integral from a to b of f of x dx, and in sum with integral from f of a to f of b of f inverse x dx, the result is just b f of b minus a f of a. So to see why does this result hold, uh, the, the visual interpretation can be a great help. Yeah. Now let's see why this thing happens. Let's say this is f of x, and here we have a, b, and the corresponding point we have f of a, f of b. So this is f of b, f of a. Okay. Now the integral from a to b of f of x is just this area. Yeah, and now when finding the integral from f of a to f of b of f inverse x dx, we can just like suppose this is now x. Initially for this integral our x was this axis. Now for this integral, if we just let x as this axis, now f inverse x will just give this same graph in this direction. If this is x, yeah, so our f inverse x will just be the same graph, and when we are going from f of a to f of b, so we will just get this area. Yeah. Okay, so I guess you get it why that happens. Now for this area we can just subtract this area of a small rectangle from big rectangle. That would be b f of b, the area of big rectangle. Yeah, because this is base and this is height, minus the area of small rectangle is a f of a. So I guess now to see why does this happen. Now after this, we are ready to answer this problem. Now we will try to take this integral in the form that we want. We want here to be plus, and we want here to be f of a, f of b. Okay, so we will try to make that. We will want to make here plus, and after we make plus, like we just have to use reflection. 1 to 0 root under 2020 1 minus x to the power 2022 dx. Now notice that if this one is f of x, yeah, our f of 0 will be 22nd root, sorry, 2022 ordered root of 1 minus 0, that's just 1, and our f of 1 will be 22nd ordered root of 1 minus 1, that is 0. So these are just f of 0 and f of 1, you can see that. And after we notice that, mm, okay, so this will just be 0 to 1 f of x dx, plus this will be f of 0, f of 1, and f inverse x dx. So this is now in the formula that we want. So this integral should be 1 f of 1 minus 0 f of 0, that is f of 1. Now our f of x is this function. Yeah, and our f of x is 2022 ordered root of 1 minus x to the power 2020. So if you put 1 over here, it's just 0. So our integral will be 0, and that's the answer. So this is how we solve the problems of inverse integrals. Thanks for watching.